This video presentation is going to be over calculating the volume of water in a conical tank. That word is going to be fun to keep saying over and over. Anyway, as I always preface my videos, I do not own any of the questions or material presented in this video, as it was all sourced off the open internet. I, to the best of my knowledge, presented the proper formulas and correct answers, as this is a study guide and for educational purposes. If this helps you learn, that's great. If you have ever watched any of my other videos, you will know that I like to pull my formulas off the state of Florida formula sheet. Well, guess what? Joke's on you today, as Florida does not actually include this formula on its sheet. So this is actually off the ABC formula sheet. Either way, I like to always recommend that you find the formula sheet your testing agency uses and get familiar with it when practicing the math. There should be a link to a brief video I do that goes over different states having different formula sheets. So to find the volume of a cone, it is 1/3 times 0.785 times the diameter squared times the height. I've also included the volume of a cylinder, 0.785 times the diameter squared times the height, because a lot of times things like clarifiers, they're going to be cylindrical on top and they're going to have a cone or be conical on the bottom. Again, that word's going to be fun to keep saying. So here you have a picture of a cone. So the volume of a cone is 1/3 times 0.785 times the diameter, which is the length across the circle, times the height of the cone. Sorry, no ice cream. So here we have a diagram of a tank with a conical bottom. So you're going to end up breaking this volume problem into two parts where you solve separately for the volume of the cylinder, which is going to be the diameter 1 of the cylinder and the height of the cylinder. Right? Those are horribly highlighted. And then you're going to solve for the volume of the cone. So you have the diameter of the cone, which should be equal to the diameter of the cylinder, times the height of the cone, right? And then you're going to end up adding them together once you solve them separately. So let's practice these questions. What is the volume of a conical tank in gallons that is 12 feet in diameter and 11 foot in height? So first we're going to pull out our known and our unknowns. What you know is the diameter is 12 feet and the height is 11 feet. What you don't know is the volume in gallons. So this is a conical tank, so it's just the cone itself. So the volume of a cone is equal to 1/3 times 0.785 times the diameter squared times the height. Remember, in water treatment, you're usually solving for cubic feet. So we got to make sure all of our units of measurement are in feet, which they are, so we can plug them into the formula. So you have 1/3 times 0.785 times 12 foot squared, so 12 times itself, times 11 feet. We can do the multiplication. So the volume of the cone is 414.48 cubic feet. Remember, it's asking for gallons in the tank. There are 7.48 gallons per cubic foot. Remember, anytime you do unit conversion, the unit you want to cancel out goes on the bottom. It's dead, it's buried, it's underneath. We don't want it anymore. So you write it 414.48 cubic feet times 7.48 gallons over 1 cubic foot. The cubic feet will cancel out and you'll be left with gallons. So do your multiplication. And the volume of this cone is 3,100.3 gallons. What is the volume of a conical tank in gallons that has a radius of 10 feet and a height of 17 feet? Always pull your known and unknowns out so you can keep track of them easily. What you know is the radius is 10 feet, the height is 17 feet, and you're looking for the volume in gallons, which tells you you're going to need a volume formula. The volume of a cone is 1/3 times 0.785 times the diameter squared times the height. Wait a second, they gave us the radius instead of diameter. This formula won't work. Be careful, questions will try to trip you up. There's two things we can do here. We can either multiply the radius by 2 because the diameter is twice the length of the radius, and then we can continue to use this formula. Or if you've seen volume formula for radius, we can substitute 3.14 for the 0.785. I have a link to cylinder volume videos if you need a refresher. It'll be in the corner, and then you can just do some volume practice. Either way, we're going to solve this both ways on this video. So first we're going to find the diameter, which is twice as long as the radius. So you're going to add it together. So radius plus radius equals diameter. That's 10 feet plus 10 feet. And you get an answer of 20 feet. So now we can plug this in for our diameter because we're already in feet. So you have the volume of the cone is 1/3 times 0.785 times 20 feet squared times 17 feet. And then here is the formula to solve with the radius itself, which is 1/3 times 3.14 times the radius squared times the height. So it's 3.14 for the radius, 0.785 if you have the diameter. So we can plug in our 10 feet for our radius squared times 17 feet times 3.14 times 1/3, and you can solve the math for this written both ways. So we solved it both ways, and we got the same answer both ways. 1,779.3 cubic feet, whether you do it 3.14 times the radius, or if you do 0.785 times the diameter. Either way, we're going to have to convert this into gallons. So 7.48 gallons times 1,779.3 cubic feet. You get it multiplied, the cubic feet will cancel out. So 1,779.3 cubic feet times 7.48 gallons over a cubic foot. And the answer is 13,309.2 gallons. All right, so now we'll get into questions with cylinders with conical bottoms, like a clarifier. A tank is conical at the bottom and cylindrical at the top. If the diameter of the cylinder is 18 feet with a depth of 32 feet and the cone depth is 12 feet, what is the approximate volume of the tank in gallons? So first we're going to pull out the known and the unknowns. So what we know is the diameter is 18 feet, and that's the diameter for both the cylinder and the cone. We also know the depth of the cylinder is 32 feet, and the depth of the cone is 12 feet. What we don't know is the volume in gallons. So the volume for a cone is 1/3 times 0.785 times diameter squared times the height. Everything's already in feet, so we're going to plug it in. So 1/3 times 0.785 times 18 feet squared, so 18 times itself, times 12 feet. So you can either multiply the 1/3, the 0.3333, or you can just divide by 3. So you can actually do 0.785 times 18 feet squared times 12 feet and divide it by 3. And it's a little bit easier if you have a junk calculator, which is probably what you're going to have on the test because they don't let you use your phone. They let you use a pretty crappy solar-powered calculator in Florida anyway. So when you do that math, the volume of the cone is 1,017.36 cubic feet. So we have the volume of the cone. Now we're going to solve for the volume of the cylinder. The volume of the cylinder is 0.785 times diameter squared times the height. Everything's already in feet. So you had a diameter of 18 feet squared times the depth of the cylinder, 32 feet, times 0.785. And the volume of the cylinder is 8,138.88 cubic feet. So now we have the volume of both the cone and the cylinder. So what we're going to do is we're going to add those together to get the total volume. The total volume is the volume of the cone of 1,017.36 cubic feet plus the volume of the cylinder, 8,138.88 cubic feet. There goes my voice. So the total volume is 9,156.24 cubic feet. Now we want gallons, so we're going to multiply this by 7.48 gallons per cubic foot. Remember, when you want the thing to cancel out, it goes on the bottom, it's dead, it's buried, it's underneath. So 9,156.24 cubic feet times 7.48 gallons over a cubic foot. The cubic foot / feet will cancel out and you'll get gallons. So multiply. And the volume of the tank is 68,489 gallons because I went ahead and rounded. A 24-foot diameter tank has a conical bottom. The side water depth, top of cone to water surface level, is 20 feet. The cone is 6 feet deep at its deepest point. What is the volume of the tank in gallons? All right, first let's pull out our known and our unknown from our word problem. So what we know is a diameter of 24 feet, the depth of 20 feet in the cylinder, and the depth of the cone is 6 feet. What we don't know is the volume in gallons. So first we're going to solve for the volume of the cone. So 1/3 times 0.785 times the diameter squared times the height. Everything's already in feet. So 1/3 times 0.785 times the diameter of 24 square feet, because remember the diameter for the cone is the same as the cylinder, times the depth of the cone, which was 6 feet. When you do your multiplication, you get 904.32 cubic feet. So now we need to solve for the volume of the cylinder. Volume of a cylinder is 0.785 times diameter squared times the height. Everything's in feet, so we can plug it in. So 0.785 times the diameter of 24 feet squared times 20 feet. Do your multiplication, and you get 9,043.2 cubic feet. And now we can add the volume of the cylinder to the volume of the cone, which was 904.32 cubic feet. So 904.32 cubic feet plus 9,043.2 cubic feet will give you the total volume. That's 9,947.52 cubic feet. We want this to be in gallons. So we're going to multiply it by 7.48 gallons per cubic feet so that the cubic feet cancel out. So you can do your multiplication, and you're left with 74,407.5 gallons. A chemical tank is conical at the bottom and cylindrical at the top. If the diameter of the cylinder is 27.8 feet with a depth of 39.9 feet and the cone depth is 12.6 feet, what is the volume of the tank in gallons? So start by pulling your known and unknowns out. The diameter of the cylinder, 27.8 feet. The depth of the cylinder is 39.9 feet, and the depth of the cone is 12.6 feet. Again, we're looking for the volume in gallons. First, we'll do the volume of the cone. It's still 1/3 times 0.785 times the diameter squared times the height. Now remember, the diameter of the cylinder and the diameter of the cone are the same. So we're going to plug these in because they're already in feet. So 1/3 times 0.785 times 27.8 foot squared times 12.6 feet. When you do the math, you get 2,548.05 cubic feet. Now that we solved for the volume of the cone, we can solve for the volume of the cylinder. Volume of a cylinder, 0.785 times diameter squared times the height. Plug everything in. You have 0.785 times 27.8 squared times the depth of the cylinder, 39.9 feet. Do your math. You end up with 24,206.51 cubic feet. So now we can add the volume of the cylinder to the volume of the cone, 2,548.05 cubic feet. So when you add those together, the cone, 2,548.05 cubic feet, plus the cylinder, 24,206.51 cubic feet, your total volume is 26,754.56 cubic feet. And again, we are looking for gallons. So you multiply that by 7.48 gallons per cubic feet. Cubic feet cancel out. You're left with gallons. And the answer is 200,124.1 gallons. So there you have how to solve for the volume in a conical tank. Hopefully you enjoyed me trying to pronounce that word a whole bunch. Hopefully this video helps you learn. Thanks.